again children. Today I am going to start a new chapter, that is gravitation. You all must have read this chapter. So first I am going to summarize all the concepts and then we can solve some numericals to clarify all the concepts. So let us get started.
Gravitation. With the name gravitation itself, the first name that comes in our mind is that of Newton. But it is not only Newton. So many scientists and astrologers have given their contributions in deriving all the laws related to gravitation. The first was the mathematician 𝕆𝕆𝕍𝕆. He had studied motion of all the planets of celestial bodies, moon, earth, and then wrote conclusions in his book. He only established that the earth revolves about its own axis. He also gave description of motion of other celestial bodies as seen from the earth. After 𝕆𝕆𝕍𝕆, Brahe and Kepler, they were the combination who studied planetary motion in great detail and then formulated some very important findings which we will discuss in our coming session, and that is very famously known as the 3 laws of planetary motion. But before that, let us see what is the law of gravitation that was given by Newton. As we know, gravitational force is the weakest force among the 4 fundamental forces of nature. But it is the most important force, we can say, because it plays a very important role in initiating the birth of stars and controlling the entire structure of the universe. So the gravitational force has significant application in the present advancement of physics, we can say. The law of gravitation was discovered by Newton in 1665 when he saw a fruit falling down from the tree. And what is Newton's law of gravitation? As you can see here, it states that every body in this universe attracts every other body with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. So if we write this force mathematically, then according to Newton, F can be written as proportional to m1 m2, where m1 and m2 are masses of the two bodies, upon r square, where r is separation between the bodies. And on introducing a constant, we can write this F to be equal to g m1 m2 upon r square. This constant is known as universal constant of gravitation. So this is constant of gravitation. Now how can we define this gravitational constant g? Let us substitute m1 and m2 both to be equal to 1 and r also to be 1. Then of course we can write F as only it will be g numerically. So we can say that universal gravitational constant is equal to the force of attraction acting between two bodies, each of unit mass and whose centers are placed unit distance apart. If we calculate its value practically, then value of g is found to be equal to 6.67 into 10 to the power 11 Newton meter square per kg square. And in CGS system, this can be written as dyne per centimeter square per gram square. Now, what is the dimensional formula for g? We can derive from the formula F is equal to g m1 m2 by r square. So directly dimensional formula of g from here can be written as it will be m minus 1 L cube t minus 2. Now what are the evidence in support of Newton's law? Have you ever experienced Newton's law? Practically, so many things we can explain with the help of Newton's law of gravitation. The first is rotation of earth. Rotation of earth can be explained by Newton's law of gravitation. So, rotation of earth around the sun or even motion of moon around the sun can be explained on basis of this law. The other evidence that we can give is prediction about solar and lunar eclipses. We can predict solar and lunar eclipses with the help of Newton's law of gravitation. And these always come out to be true. The third evidence that we can give is that formation of tides in the ocean is due to force of attraction between the moon and ocean water. So this is formation of tides in the ocean. One more evidence we can see, the prediction about the orbits and time period of modern artificial satellites, because now with help of this law we can predict so many parameters for the artificial satellite which are found to be very accurate. So these only 4 I have written here, though a long list can be there in support of Newton's law. So many things can be explained with the help of Newton's law. Now how can we write this Newton's law of gravitation in vector form? So in vector form, let us consider here is point A, this is another point B, which are a distance r apart. The masses are kept at A and B. Let that be m1 and m2. Then we can write, now position of A with respect to B will be in the direction of vector that has to be towards A. Similarly, we can write position vector of B with respect to A and its direction has to be towards B. So if we write now force on A due to B, as we know this is the attractional force, so on A due to B I am writing force on A due to B that can be vectorially represented as G m1 m2 upon r square, and then unit vector we can write here. Now what should be the direction from A to B or from B to A? As A is being attracted by B, so the direction has to be towards B. And here we can write this unit vector RBA. Similarly, if we have to write force on B due to A, that can be written as G m1 m2 upon r square, and this time the direction has to be unit vector which is towards A. So it has to be RAB. So this is how vectorially we can write Newton's law of gravitation. And you can see from here that FAB is equal to minus of FBA, because both RAB and RBA are having the same magnitude, only they are opposite in direction. So from this Newton's third law also is derived. Now let us see what are the important characteristics of gravitational force. The first characteristic is that it is independent of the medium. It does not depend whether there is any solid medium or liquid or gas or vacuum between two masses. So it is independent of medium. The second characteristic is that it is independent of presence or absence of other bodies. So it is independent of presence of other bodies. That is why we can apply superposition theorem as well for the gravitational force, which we will see later. The third characteristic is that it is independent of nature and size of the bodies till their masses remain the same and distance between the centers is fixed. So as far as m and r are fixed, gravitational force has to be constant. This value will change only when masses are changed or distance between their centers are changed. The next characteristic is that it forms action and reaction pair, as now just we have seen it. So always we can write this FAB has to be equal to minus of FBA. Also it is a central force because it acts along the line joining the center of the bodies. Here you can see, since F is proportional to unit vector along R, so this kind of forces are called central force, and gravitational force also is a central force. The last and the least one is that it is conservative in nature. Always all inverse square law forces are conservative, so this also is conservative in nature. So these are the all characteristics we have discussed about gravitational forces. What next now? One illustration I have to clarify how the gravitational force between two masses can be calculated. The mass of planet Jupiter is given this much and mass of Sun is given here. Let us first write these values. Mass of Jupiter is 1.9 into 10 to the power 27 kg. Mass of Sun is 1.99 into 10 to the power 30 kg. Calculate the gravitational force which Sun exerts on Jupiter, assuming that Jupiter moves in circular orbit around the Sun, and also calculate the speed of Jupiter. Value of gravitational constant G is provided here. Now, if we put the values in force, that will be equal to G mass of Jupiter into mass of Sun upon distance among these two bodies. This will come out to be 6.67 into 10 to the power minus 11 into 1.9 into 10 to the power 27 into 1.99 into 10 to the power 30, and this whole divided by 7.8 into 10 to the power 11 and then square of this. So this value will be equal to 4.15 into 10 to the power 23 Newton. This is the force between the planet Jupiter and the Sun. Now, since gravitational pull of Sun on Jupiter will provide it the required centripetal force to Jupiter, therefore the velocity of Jupiter can be calculated by using this F should be equal to mv square by r, which is the centripetal force here. From this we can write V to be equal to under root F r upon, now this mass has to be mass of Jupiter, so upon mass of Jupiter. Now when I substitute all the values, the final result will come out to be 1.3 into 10 to the power 4 meter per second. It is the speed of Jupiter when we assume its orbit to be circular around the Sun. One more illustration I have. Two particles of masses m1 and m2 initially at rest at infinite distance from each other move under the action of mutual gravitational pull. Show that at any instant their relative velocity of approach is this much. We have to calculate relative velocity of approach and then check that whether it is equal to this value given or not, where r is their separation at that instant. Okay, let us start with the gravitational force. So if I write gravitational force on m1 due to m2, which is at separation r, it can be written as F1 is equal to G m1 m2 upon r square. Now acceleration of m1 can be written as, I am denoting by a1, that has to be equal to F1 upon m1, which is G m2 upon r square. Similarly, we can write acceleration of m2 also, that will be a2 being equal to minus G m1 upon r square. This time I have put a minus sign because these two accelerations has to be opposite to each other. Now the relative acceleration if I write, that will be equal to a1 minus a2, and which will be G m1 plus m2 upon r square. So if v is the relative velocity, then we can write ar to be equal to dv upon dt, which can be written as dv by dr into dr by dt. Now since v is the relative velocity of approach, so we can write v to be equal to minus dr by dt, and if I substitute this value here, it will be minus v dv by dr, and which will give v dv to be equal to minus ar dr. Now I can substitute value of ar from above, that will give minus g m1 plus m2 upon r square dr, which on integrating will give v square by 2 to be equal to G m1 plus m2 upon R. Now when this R is equal to capital R, which is given in the question, so value of V will be equal to under root 2G m1 plus m2 upon R. That we had to prove. This is the relative velocity of approach between the bodies. Now, as I had discussed while discussing about characteristics of gravitational force, that it is independent of presence of another bodies, and that time I had said due to this characteristic we can apply principle of superposition. So principle of superposition can be applied for gravitation also. Now let us see what is principle of superposition. It states that if a resultant gravitational force is acting on a particle due to a number of different particle masses, then it will be equal to F on 0 due to 1 plus F on 0 due to 2 plus if total n number of particles are there, so it will go till F on 0 due to n, and this can be written as summation of F0i, where I is from 1 to n. This is called superposition principle. Directly we are writing the forces due to each particle and then taking vector sum of all the forces to get the total force due to all the particles. This is called superposition. In vector form it can be written as F0 to be equal to, if G m0 can be taken outside, then it will be summation of all other terms, that has to be m1 r01 upon r01 square plus m2 r02 upon again square of mod of this r02, and will go till nth term, that is mn r0n upon r0n. In this way we can get the resultant force on any particle due to a number of particles. Let us see now with help of numerical how this concept can be applied. The first question is, a solid sphere of lead has mass capital M and radius r. A spherical hollow is dug out from it. Its boundary passes through the center, also touches boundary of the solid sphere. Deduce the gravitational force on a mass m which is placed at point P at distance r from O along the line of centers. Let us see how this can be calculated. Now if O be the center of solid sphere and O dash be that of the hollow, as it is seen here, then for an external point the sphere will behave as its whole mass is concentrated at its center. So gravitational force on a mass m at P can be written as force on P I am writing, so it should be equal to force on P due to the bigger sphere plus force on P due to the smaller sphere. And as diameter of smaller sphere is r, so its radius has to be equal to r by 2. Now we can write values of these forces. For the bigger sphere it has to be equal to g. Mass of this particle mass is small m. For bigger sphere it is capital M upon the distance. Distance is given as r square. With this now we have to add the force due to the smaller sphere. Now do consider, because this smaller sphere is actually a cavity, so it can be assumed as that a negative density small sphere has been superposed at this place. Now the smaller sphere will be having mass that is 1 by 8 of the bigger one. So we can write mass of smaller sphere to be equal to minus m by 8, because we are assuming that it is made up of a material of the same density as the bigger one but having negative value. So its mass will be equal to minus m by 8, and then if I apply it here, this will be g small m and then minus m by 8. What is its distance of P from the center of smaller sphere? That has to be equal to r minus r by 2. Now on solving these, we will get final answer to be equal to g m m upon r square 1 minus 1 by 8 can be taken outside. This will be 1 minus r by 2r and then square of this. So it will be the resultant force on particle P due to this remaining shape. Let us consider one example. Two spheres of mass small m and capital M are situated in air and the gravitational force between them is capital F. The space around the mass is now filled with a liquid of specific gravity 5. The gravitational force will now be. Different options are given here. One is 3F, second is F, third is 5G and the fourth is G. As we know that we have to calculate force, so its value cannot be equal to 5G or E or G because these two are the acceleration terms. So correct answer on first side itself can be said as either it will be A or B. But as the gravitational force is independent of the medium separating the masses, so its value will remain the same. And then the correct option we can write as it will be option number B, which is the sought result. One more question I have. 3 particles each of mass m are located at the vertices of an equilateral triangle of side A. At what speed must they move if they all revolve under the influence of their gravitational force of attraction in a circular orbit, circumscribing the triangle while still preserving the equilateral triangle? Okay, let us first draw the equilateral triangle. This is triangle A, B and C, and 3 particles of mass m each are located at these 3 vertices. The total angle is 60 degree. Now here it should be geometrical center for the triangle where all these 3 median intersect. Now force on attraction, if we consider on any body, let's that be on particle C, then force by A on C has to be in this direction. Let this value be F1. Also force on C due to B will be in this direction. This also will be having the same magnitude as masses are same and distances are also same. So if I write the resultant force, it will be towards middle of these two, that has to be equal to F can be written as this will be F1 square plus F1 square plus 2 F1 F2, that is F1 square again cos 60 degree. That will give root 3 times F1. Now what is F1? F1 has to be equal to gm square upon a square because distance between two particle masses are a. So it has to be root 3 gm square upon a square. This should be along the direction OC, which is shown here in the diagram. Now OC can be written as this should be 2 by 3 of CD, and CD is AC sin 60 degree. So it will be equal to 2 by 3, AC is A itself, and then sin 60 degree is root 3 by 2. From here we got value of OC to be equal to A upon root 3. Now if I substitute this value, then we can write F to be equal to root 3 gm square upon a square, and that should be equal to the necessary centripetal force as all the masses are moving along a circle for which O is the center. So it should be equal to mv square by r. Now what is this r? This r should be equal to the length OC. So that is equal to A upon root 3. Now on calculating these values, we will get V to be equal to root under gm upon A. With this, our today's introduction of gravitation is completed. In the next session, we will move further to study about more topics that is in gravitation and then solve some more numericals. Till then, keep safe. Goodbye.